Hi everyone, today I'm going to share with you two important topics in chemistry, which are standard solution and also dilution of solution. Okay, before we start, my very first question for you is, have you ever make a cake or even cook a dish? And of course, you need to know the exact amount of flour, sugar, and eggs, right? So, while making a standard solution is exactly the same. In chemistry, we need to know the exact concentration of our solution, just like the chef needs to know the exact amount of ingredient they need in a cooking. So to make a standard solution, we need some special tools. For example, we need analytical balance, volumetric flask, weighing bottle, filter funnel, pipette, distilled water bottle, and finally a dropper. So our next question is how to prepare a standard solution. So for the details step, I think you can refer to the slide, but actually I have generated a quick visual summary for you to see or to look at the whole process. So now let us put this into practice with an example. So the question is, calculate the mass of NaOH needed to prepare 100 ml of a 0.10 m NaOH standard solution. So first, we need to find the number of moles. Do you still remember the formula? Which is the number of moles equals to concentration times with the volume. So when we substitute the value given into this formula, and then we will know that we need 0.010 moles of NaOH. And the second part, we need to convert the number of moles into grams so that we can actually weigh it. Alright, so we will use the formula. The number of moles equals to mass divided by molar mass. And given that molar mass of NaOH is 40 grams per mole. So, and then we will rearrange mass equals to number of moles times with molar mass, and we plug in the numbers. And finally, we will get the answer, which is 0.40 grams. So, alright, so now we're going to move to the second part of our lesson today, which is dilution of solution. When we're talking about dilution, there is that one formula or rule that you have to always bear in mind, which is M1V1 equals to M2V2. So after learning about the dilution formula, I think this is time for us to take a mini challenge. Alright, so we need to help our friend Josh, the chemist, to solve his problem. Let us see what is the problem faced by Josh in this video.
Oops, I only have a 1.m stock solution. So I need to prepare 100 milliliters of 0.1 m solution. Can you solve it before time runs out?
Alright, so I hope you can understand what is the situation. Firstly, you need the dilution formula, which is M1V1 equals to M2V2. But before all, you need to know the value for each one. So in this case, M1 equals to 1.0 m, which is the stock concentration. M2 equals to the 0.1 m, which is the concentration that Josh wants, and V2 equals to 100 ml, the final volume that Josh needs. So in this scenario, actually, we're going to find V1, which is the volume that Josh needs to take from the stock solution. So as usual, we need to go through a bit mathematical process by substituting the numbers into the formula, and lastly you get V1 equals to 10 ml. So, congratulations because you have learned all the basic concept and calculation in this topic. But before we end this session, I would like to share with you why actually standard solution and dilution matters in our everyday life. So, standard solutions are actually everywhere. In water treatment, for example, they help to determine how much chemical to add to the water to make our drinking water safe. And lastly, for dilution, you might not realize that you are actually using dilution concept in your daily life. Even when you are making a glass of syrup drink, you are actually using dilution because you would need to dilute the concentrated stock with water. And before I end this session, I have my very last question for you, which is, what do you think it will happen if you accidentally use tap water instead of distilled water in preparing your standard solution? Would the concentration be affected, or how would it impact your experiment? So think about it. That's all from me. Thank you so much for watching and happy experimenting. Before I end this